And the next session is devoted to reports from various very interesting, wonderful centers, HPC centers in Europe. Our first speaker at the conference is Valentin Plugaru, who is the Chief Technical Officer at LUX Provide High Performance Computing Center in Luxembourg. Valentin, with over a decade of passion and experience in all things HPC, has worked as part of national and European HPC initiatives, helping shape the roadmap for the European HPC ecosystem and creating Luxembourg's first national HPC center and supercomputing platform. Today, he is sharing his time between boosting LUX Provide's HPC data and AI capabilities, growing highly expert groups, and supporting the development of competencies networks, in particular through the EuroCC National Competency Centers and CASTIEL projects. Valentin, my friend, welcome you to the conference. Good afternoon. The floor is yours. Thank you very much.
Thank you very much for the beautiful introduction. So please allow me to introduce myself. I am Valentin Plugaru. I am the Chief Technology Officer of LUX Provide. I am deeply pleased to provide you a few ideas about what we have built at LUX Provide. We are a newly established center for supercomputing in Luxembourg, in the Grand Duchy of Luxembourg. The picture that you see before you is the data center where MeluXina is hosted in the right side. We are a hosting entity for EuroHPC joint undertaking with the MeluXina supercomputer, which has been designed as a mid-range petascale level supercomputer and is joining into the network of new generation European supercomputers. We are not only providing national supercomputing and data infrastructure, we are also part of the European Competence Centers Initiative, EuroCC. And our goals are not only to provide computing time, but actually to guide users into their HPC, data analytics, big data, and AI projects, to empower Luxembourg's digital ecosystem while linking deeply with the key areas of Europe. I would like to say a few words of supercomputing. Well, knowing this is a supercomputing frontiers, people are well accustomed to the concepts, yet what it actually means to do supercomputing really needs to be highlighted. Especially as in the past 1 year, more than 1 year now, we really see supercomputing helping all the way in medicine, in personalized medicine, helping do drug design, helping with the COVID crisis. Yet even in the past week, we were subject to another type of natural disaster. So severe weather conditions are, at least in Western Europe, very, very clear. And this is where supercomputing will help. So doing better prediction, helping to activate early warning systems, and then to prevent as much as possible disasters that are impacting us at multiple levels. For industry, supercomputing brings either new products to market faster, so just enabling to do things in a faster way, but it also helps minimize costs, doing things more efficiently than before. And finally, it's able to provide things, doing simulation, digital twins of where you are not able to do that without having in the back a supercomputing platform. For science, well, supercomputing came out of the needs of science. Many of the recent breakthroughs were not possible to, would not have happened without supercomputing in the back. There's some chemistry and physics Nobel Prizes that where supercomputers were very much in the back of the discoveries. And we see this as a general trend. So supercomputing to help uncover new truths about our world, and also to make us to help us make sense of it all. In Europe, as you well know, there is the EuroHPC joint undertaking initiative that is piloting coordinated action now for some years. This supercomputing is meant to underpin the digital strategy of Europe. The digital decade will have supercomputing as a one pillar, then helping for both industry and research, for researchers that are all over Europe, not only in the 8 sites that have been chosen to host the next generation supercomputers. Yes, yet only infrastructure is the first part. Competencies are very much needed to be able to take advantage, to efficiently and effectively use supercomputing facilities. High performance computing is done with the help of supercomputers. Data analytics can be brought to the next level by doing high performance data analytics, and AI as part of both supercomputing codes and doing better decision making systems. And require competencies that are now being done and are being piloted through the national competence centers. There's 33 participating countries in Europe here. The Luxembourg one is joint collaboration between the Lux Innovation, University of Luxembourg, and Lux Provide. And the European competence centers are actually providing a broad service portfolio, and there's many actions, including technology transfer and collaboration with industry, where one target is to bring SMEs to take advantage of these kind of facilities, where maybe there are some gaps in knowledge, in training, or in competencies, which the competence centers are supposed to provide. And then there's a deeper coordination happening between all of the national competence centers through the CASTIEL project that is gluing together this European network. I will spend most of my time today with you to talk about MeluXina. The vision for MeluXina, the National Supercomputer of Luxembourg, has been to serve really a large variety of workloads to help with this convergence of pure simulation modeling, that is traditional HPC, to bring data first and foremost into these facilities and into the loop, and having AI permeate all kind of applications and application domains. Luxembourg's key sectors in smart mobility, financial services, healthcare, industry, logistics, and space will all be able to be accelerated with the help of supercomputing facilities, and the infrastructure that we have put in place and the platform that we're putting in place will help with those domains. Just to remark on a few deeper use cases of where we see supercomputing will help. If you want to send a new satellite in space to maybe to look at how forests grow, how biodiversity is happening or is being lost, and to recover from that, you need to send the satellite in space. You need to do simulation of and forecast of space weather. You want to know where objects are on the in space to be able to send safely a satellite there. Then you need to be able to do a lot of simulation and data analytics to make this happen. You want better sensors, you want better materials, you want to design next generation satellites, you want to analyze the data coming from those satellites as it happens in or almost in real time. These things are being accelerated with supercomputers. Manufacturing, engineering, you're able to do digital twins of real processes, of real infrastructure. You're able to do predictive maintenance of material, of facilities. For fintech, for financial, in the financial sector, you're able to do modeling for the whole economy is the goal. Yet you're able to look at portfolio simulation. You're able to do fraud detection, so helping with security of transactions. And there's other fields that are really well known for supercomputing, like climate and weather. But now we are able to do this in much more precise way, and then you're able to do healthcare in a better way. You're able to do a digital twin of the human body. You're able to test the human body response to new drugs before actually trying this in a clinical way. For mobility, you're able to do better logistics, better networks. You're able to build better cities. How you are doing this, a single platform with a single type of computing systems in the back is not sufficient. The way the MeluXina supercomputer has been designed was with a modular architecture where you have different kind of modules for covering different kind of needs, all together linked in a joint fabric, in a very fast supercomputing fabric, InfiniBand fabric, and with a large storage infrastructure with different tiers that are helping accelerate the different parts of data workloads. So MeluXina has 3 computational tiers: a cluster module with a CPU-only nodes, an accelerator module with the CPU, GPU hybrid nodes, and CPU FPGA hybrid nodes, and the large memory module with capabilities for in-memory, large memory capabilities. Coupled to this is a cloud module for high-level services and the system module that is piloting the logic on the system. And there is excellent network connectivity both to the GÉANT network that is linking many supercomputer sites in Europe, and also to the public internet. The building blocks are for MeluXina are AMD CPUs. So there's over 90,000 CPU cores in the system. There's 800 HPC AI accelerators, NVIDIA GPUs. There's almost half a petabyte of memory, of RAM memory inside the system, enabling both use cases that we are foreseeing for today and the ones that can come some years from now. There's a tiered storage where the main building block is of 20 petabytes, yet it can be extended. And also there is a tape library that can hold data for much longer than, which is coming as a need of reproducible science. And all of it is glued together with a Dragonfly Plus topology based on the InfiniBand HDR technology, which is enabling easy extension into the future, and a rich software ecosystem on top of it to be able to take advantage of all of this platform. Some numbers regarding the performance of the system. MeluXina is an 18 petaflop supercomputer. That's a peak aggregated performance, knowing that the main computational modules, the cluster and accelerator GPU, are ranked as in the top supercomputers lists as a 2 petaflop computing power, effective computing power in the LinkPack benchmark on the cluster module, and there's over 10 petaflops that the accelerator GPU module is capable of. But that's for the all-purpose cluster module, and that's for the accelerated module of MeluXina. Specialized workloads would be able to use the FPGAs or the large memory capabilities to do other kind of work, or being part of pre-processing or post-processing workflow. So it's the workflow aspect here that is the most important. On the data side, there's different tiers from half a petabyte on full flash with ultra high performance for very intensive I/O operations, to main capacity tier that's also very fast, to tiers that help with redundancy for different kind of projects. And then there's the different interconnects that are inside the system for linking both deeply the system inside, and then with excellent external connectivity. The MeluXina system has been ranked in the top list of this year. It's maybe foremost the Green 500 result came up very nicely as the first, the greenest system in the European Union, with the accelerator module based on the very efficient GPUs, and the 4th in the world in the Green 500, while we are number 10 in the EU and 36 in the world on the computing part. Yet those only show part of the picture, so the pure computing and throughput speed. But there's graph analytics workloads, I/O-oriented workloads, and data-oriented compute workloads where MeluXina has been also ranked quite highly. The different kind of technologies that are part of the system. So I already mentioned AMD CPUs, NVIDIA GPUs. The ratio of computing nodes is really dependent on the kind of use cases that you're going to see after, and the relationship between the type of highly fat nodes with a lot of cores and the memory that you have on them, closely coupled with the InfiniBand interconnect. Those are things that you really need to take care of, and this is something that is very specific to the different supercomputers. Even within the new generation supercomputers in Europe that we see coming up as part of the EuroHPC network. There is a rich software ecosystem on top of the system. We already said that there's a lot of challenges that come of having different partitions of the system, different modules with different kind of architectures in the back. You can only do this by relying on community tools that are helping deploy toolkits and are able to test and do performance functional tests and doing continuous upgrades as the world is the software world is and the ecosystem is constantly evolving. So for MeluXina, we're planning a rich software system that is coming from pure compilers, performance tools, general purpose languages, different kind of MPI suites, libraries and frameworks, and in the end user applications that are really providing the value for the end users of the platform. I can really say nothing more about of that, except that container workloads is something that we expect to see quite a lot, especially as people are able to bring additional tools and control the complete software stacks on the system. And this has to happen in an unified way on the system, such that different kind of workloads are able to take advantage either of a native software stack, containerized software stack, and doing a flow from preparation of the application to running the computational models on the different modules, doing an analysis of all of it, and this to happen not only as a single cycle but as a continuous process. Being able to take advantage of the modular concept is something that is not really innovative. Yet what is going to be innovative is the way people are taking advantage of it. Maybe a few words to leave you on some pictures. This is MeluXina earlier this year. When the system was brought on site and the integration started. The system was first powered up earlier this year in March and has been undergoing very strict testing and acceptance process. Our next steps are to bring the system up for amazing science and innovation, and the early access program should soon start to bring the first results that are actually computed on the supercomputer. I would like to thank you for your attention. I hope that this has sparked your interest into what we're doing and will lead to discussing together into the future. Please visit our website luxprovide.lu or drop us an email if you are interested to start a conversation together. Yet for now, I wish you an excellent conference ahead, and thank you very much for your attention.
Thank you very much, Valentin. That was very, very interesting, and so good to see Luxembourg installing this very, very substantial supercomputer. I don't see questions from the audience yet, so let me ask. We have a few minutes. Questions and answers, and I encourage all our participants to ask questions, send them off, and we'll be asking all the speakers. So my question is, what are the specific topics, scientific topics that will be of the greatest importance for Luxembourg scientific community, and also how access will be provided for scientists from other countries?
So maybe I will start with the second question. Thank you very much for that. So as a hosting entity as a petascale hosting entity for the EuroHPC JU, around 35% of our computing time is going to be delivered to Europe. The GU, I think there's a much better presentation than I could do on what the GU is doing a bit later today, which will include likely some hints about the program and the different tracks, where there will be a benchmark and development calls, regular access calls specific to industry, and for both kind of production workloads and more explorative ones. So, as a hosting entity for EuroHPC, European scientists will be able to take advantage of MeluXina, and we can't wait to see what kind of projects they are going to bring to our attention and to our system. From the Luxembourg side, at least in terms of scientific applications, we have had an early access program that had tens of projects coming to say, okay, we want to take advantage of the system, want to check how our code is running, and they vary from pure simulation to molecular dynamics applications. So I believe some of the specificities of Luxembourg in terms of space industry would come up with a lot of things that are maybe data driven, so not molecular dynamics or fluid dynamics, but rather doing machine learning on imagery, space imagery, or developing new materials for space applications. In healthcare, in personalized medicine, we are hosting some excellent research institutions that are focusing on, for example, on Parkinson's disease. COVID research is something that is really not only Europe but worldwide happening, and we would be surprised not to see some kind of workloads for that happening from life sciences, meaning so maybe it's genomics, or it's doing drug design, or any other kind of application that is tied to healthcare, to personalized medicine. So
Thank you very much. Thank you very much, Valentin. You have all seen the links, contact details for Valentin. So if you have further questions, or you would like to follow the developments in Luxembourg, please do so. Thank you very much, Valentin.